All right, everybody. It's about the top of the hour, or the top of the time slot anyway. Let's see. You've got an echo. Oh, there we go. Must have been the platform. I have only got one audio device hooked up to my computer, so I don't know how else that would happen. So if there's any other audio issues, though, please let me know. Or if any of the video isn't coming through smooth, please feel free to use the chat to let me know. I'm Ed Charbeneau. I'm here to talk about secrets of a Blazor component artisan. It's just a fancy way of saying we're going to talk about building components with Blazor today. We're going to look at some of the ways that the component architecture can work in our favor, and how to make like list-bound components and things like that using the Blazor framework, and make things easy on ourselves. I think the learning curve for Blazor is pretty small, and I'm just going to show you some tips to help you get started building Blazor components very quickly. My name is Ed Charbeneau. I'm a developer advocate with Progress Software. You might know us by the TaleLearnCode brand of UI components. I'm currently working on the TaleLearnCode UI for Blazor set of component libraries for the Blazor framework, obviously, and we have lots of great stuff there. I'm a Microsoft MVP for the 5th year in a row. Really enjoying working with the .NET community and doing events like this one. I wrote a book about Blazor that you can get for free. I'll give you the link here at the end as well. But you can grab that off the TaleLearnCode website or my own website at edcharbeneau.com or TaleLearnCode.com/whitepapers. If you're interested into getting deeper into Blazor, it's a good quick read. It's about 120 pages. I'll get you going. If you have any questions after the show today, you can always find me on Twitter, or every Friday when I'm not at an event like today. Normally on Friday at noon Eastern Standard Time, I have a Blazor live stream that I do where I'm coding. So Blazor, hopefully if you're at the session today, you know a little bit about Blazor, but Blazor is a brand new web framework from Microsoft. It lets us write web applications using .NET, and it eliminates the need for writing a lot of JavaScript. So we can do almost all of our work in .NET. We may need a little JavaScript here and there to patch things together, but for the most part, we can build all of our components right with .NET technologies because it uses things like the Razor markup language, and it's running the .NET runtime right in the browser, so we don't need to install any extra plugins or anything like that. Today, we're going to focus on the component architecture itself, and this is a really good example of how simple that component architecture actually is. So in a Blazor component, we use things like directives, which can control different aspects of our component and how they behave. For example, this one has a page directive, which gives it a client-side route. So if we were to go to our domain/counter, that would bring us to the component, and we would view it as a web page. So that's what directives do. You'll see me use different directives today, like dependency injection directives and using statements and things like those. For the most part, there's a markup area of the component. This is generally HTML mixed with a little bit of Razor markup. So we'll be using a lot of that today to design our components and write the markup for those. The code of our components is put in a logic section or a code block. This wires up all the functionality for our components, does data binding. As you can see in the example up here on the slide, we can marry together fields in our code block with the display in our markup. And we can also bind to click events and run C# functions that respond to those function delegates there, like increment count on this example would increment the counter on the page, and then the field on the component would update. This is a really common example that you've probably seen if you looked at all into Blazor. You've probably seen this counter example, and it ships with the Hello World project that you normally get with Blazor as well. So if you click through like File, New Project, you'll see this counter component in your Getting Started experience. So pretty common stuff here. We're going to move on to a little more advanced things today. And we're going to start with a simple component example and kind of work through how to advance that example with a little bit more architecture as we go. So we'll give it new features. And it's going to be pretty demo heavy here. And if you have questions at any time, feel free to ask. So the first thing I want to do is I'm going to come to my index page. And it's important to know that I don't really have anything here. This is that is special. It's kind of a pared down Hello World project. And I do have a service layer here with a simple service that generates some dummy data that we can play with. I'll get into that a little bit more as the talk progresses. But for the most part, it's the basic Hello World example, which comes with the Bootstrap framework already pre-installed for us. So we're going to use some Bootstrap to create some basic components today. The first thing I want to do is just kind of show how I normally get started when I build a component for Blazor. And I get started by just kind of hashing out what the basic HTML is going to look like for that component. So we'll start there with a simple div, and we'll use the class of alert. And then we'll also give the alert danger CSS class. This is the common way that you create a alert box for the Bootstrap framework and render that. It's not quite a component yet. It's just some HTML markup. So let's go ahead and throw a span in here. We'll just put some dummy text in here. So we have our alert box, and if I hit Control F5, we'll go ahead and build our application, and I'll show you what that page looks like. So on this blank page, I've got my alert box, and again, all the CSS is coming from the Bootstrap framework. So we have our alert box here, and it's rendering a red background and everything because it has that alert danger CSS class on it. So the next logical step here to make a component from this HTML element is to move this into an actual Razor component file. So I'm going to go over to my Solution Explorer here, and I've already got a folder set up for this called Components. You could put these components in Shared as well. I like to break mine off into a Components folder in case I want to move that entire set of components outside of my project later. And I like to keep my Shared folder for things that pertain specifically to this project only. So I'm going to move this alert box into my components folder. So the first thing I need to do is add a new Razor component. So I'm going to use the dialog here, just go ahead and create that. And we'll call this one alert box. Now that we have our alert box, I'm going to wipe out this boilerplate code. Go back to my index page, and we'll just take that code and replace or place it in our alertbox.razor file. And now that it's in our alertbox.razor file, just that easy, we can come back to our index page and say alert box. And you'll notice there's a really long namespace here. So we have Blazor Day components.alertbox. That's just the assembly name. That's the full namespace of where that alert box lives. I'm going to go ahead and back that out, and I'm going to go over to my imports file and just declare this globally so I can use it in any view or any component in this application. So we'll say using Blazor Day, and this is the namespace, and then point it at that components folder where that alert box lives. And now we can just say alert box. And if I Control F5, go back to my application, you'll see that it looks identical. So what do we actually do here? What we did is we made a repeatable piece of HTML like this. Every time we render that alert box, it renders that HTML. We could put multiple of these on our page like this and hit Control F5, and now we have 3 alert boxes. So that just shows how easy it is to encapsulate some HTML and turn that into an actual component. So let's look at how we can advance this concept a little bit. I'm not going to keep bouncing back over to PowerPoint. I'll just leave it open like this as I outline some specific terms that we're going to use. So we're going to start with a basic parameter. Parameter is a way to expose a public property on our component, and we can give the component some information to handle how it renders the output, or maybe we give it some event delegation, as you'll see later. So the first thing I want to do is add a parameter to this component. This is how it looks. It's an attribute that we put in the code block of our component. And we can give it a basic property that we can get or set the value of and display that however we like using our Razor markup. So let's start by giving our alert box a way of defining that CSS class. And then we can set not only the danger alert style, but maybe some other styles as well. So I'm going to start with a code block here. And we'll open this up. And inside of this, I'm just going to use a little snippet here so you guys don't have to watch me type. We only have so much time here, and I want to cover some stuff today. And watching me type isn't fun. So I'm going to set up a parameter with the parameter attribute. And it's a public string of CSS class, and I'm going to default that to that danger that we had before. So up inside of my class, I can actually remove this now and just put CSS class, and that behavior is going to be exactly the same, except now I have external control over that alert class. So I can go back to my index page, and I'll choose the middle one here. And you'll see that immediately I have an attribute here that I can assign a new value to, and I can say alert info, and that'll give it a completely different style. I know this is a really basic control. We don't have time to get anything super advanced today, but this kind of shows how you can control different themes and aspects of your component. And again, we can render this stuff anywhere within our HTML elements. This one's very simple. It's just using a div container for this example. So now we have our various alert boxes and our different styles that we can use. Now, the next thing I want to do is you'll notice I don't have anything inside of this tag or this component. And within the component itself, I have this static text displayed here. And it's repeated over and over again, each instance I use for this component. So I want to use something that allows other developers to take the component and display their own information inside of that component tag. So it's kind of a child content area. That's the next thing we're going to look at. So what is a render fragment and child content in Blazor? So a render fragment parameter is, by convention, a template region. So this is something that Blazor understands is going to be a template region in our component, and we can define it as child content, and it will automatically pick that up and use that child content within the component. So again, this is a parameter. So go ahead and add another parameter to our component here. And this is going to be a render fragment. A render fragment is any HTML. It's any Razor. It can be another component. It can be literally anything that we want within the Razor markup. So we're going to create a render fragment is our type, and we're going to call it child component or child content. And again, this is an implicit naming convention here. So child content is understood by Blazor as the default template space in our component. So we'll call this child content. If we were to name this, we would have to give the template region that specific name. I'll show some of that in just a little bit. But just keep in mind, if it's child content, we don't need to specify any special tag there to use that content region. So now I can say in here, child content 1, and we'll go ahead and paste these in here and change the numbering. We'll do 2 and then 3 here, because these are all different instances with different child content. So now we can display any HTML we like, any other components we want to put inside of that component. They're now rendered as child content in there. And that's just how easy Blazor is to use to create a container control like this All we need is that content region. And again, if I change the name of this child content to something else, we would have to explicitly name it, like so. I could say child content here, and we would just put the name of that template region in there, just like that. Those both mean the exact same thing when you're using the term child content. So it's all by convention. So next, what can we do with our component? Well, you'll notice that on my CSS class here, I'm using a non-conventional, non-HTML convention attribute. This is a property called CSS class. One of the negative sides of doing this as a property is there is a natural HTML attribute that we might rather use, and that's just the class keyword like this. And when we use class in this type of a context in Visual Studio, we also get IntelliSense with it, which I don't get as a property of CSS class because the IntelliSense doesn't understand that this actually translates over to a CSS class at the end of the day, so it doesn't give me any IntelliSense to help me with that. So there is actually a way to use those natural HTML attributes in Blazor. So let's take a look at how we can do that. So if I want to use attributes in Blazor, right now, if I were to go into my component and put in some sort of CSS class like this, since it's a component, let's go ahead and change this one to dark. I'll hit Control F5, and we'll see what happens with the component. You'll notice I actually have an error down here at the bottom of the page. And if I look at that error, it will say that I am using a property that doesn't have a matching name class. So what exactly does that mean? Well, it's saying that in my alert box, I don't have a parameter called class. So therefore, it's going to throw an error because I'm trying to use something that doesn't exist. Although this is an HTML convention, it doesn't understand that at the component level unless we tell it to. So that's where I'm going to use what's called attribute splatting. So this accepts a loose set of HTML attributes, which we can define how our component will handle those HTML attributes. We can interrupt that HTML attribute and render it in different places. We can modify the values of it. We can render it directly out as is. The choice is up to us, but what's nice is we have support from the framework to do that. And we do that through the @attributes directive. So on any element, we can actually declare this @attributes, and we can render out any additional attributes that are on-handled by our component. And we can also inject our own logic there to render those out however we choose. We have a special parameter value called capture unmatched values, and we'll set that to true. Capture unmatched values prevents that very error that we just saw. So this will allow us to put in literally any loose attribute that we like, whether it's a data dash, an ARIA attribute, or a class attribute, doesn't matter. It will allow those to pass through without that error now. Now, all additional attributes are an I read-only dictionary of string and object. If you think about what an attribute looks like for a class, for example, the string would be the key or class. The object is the value there. In our case, it's also a string, but the dictionary is left open-ended, so other things can possibly be passed through. And then at the end of it, we can then go back and use those attributes just like we normally would in HTML, but with the added benefit of them being part of our component, and we can custom render those things where and how we like. So let's go ahead and add that splat attribute to our logic here. So I'm going to take this @attributes, and I'm going to move this up to my div element here. And what's nice here is I've now added some functionality to my alert box, and I have full control over how this will be rendered out. So I can set default values like I did here. So this class will always have an alert class prepended to it. And then I'm going to append any value that the user has added to that class attribute. And we'll default it just the same way we did before by putting the default value to alert danger. And I can remove now this class or CSS class parameter that I had before. So I don't need a duplicate of that. So inside of this additional attributes collection here, it's a read-only dictionary. I'm going to go ahead and look at that additional attributes, and I'm going to try to get the class value out of it. And then I will turn it to a string if it exists. Again, it's coming across as an object. So I'll set that to string. If there's nothing there, I'll go ahead and just set it to empty. However, I actually do know on this component in particular that there's going to be a value there because I'm presetting a default. So we'll set that to danger so there's no opportunity to accidentally not render a CSS class if one isn't provided. But now I can remove this and I can customize that alert style if I want to with a basic class attribute. And I also get IntelliSense for that as well. So I've added some value to my component there. If I re-render it, you can see I have my red component, which is the default look and feel, and I have my dark component, which is my CSS class that I provided with the normal HTML attribute. What's really nice about this is even though I'm rendering out that class attribute here using the CSS class property value, that could actually go anywhere. So if I have a multi-tiered hierarchy here of elements, I could put that CSS class anywhere in that chain of elements where I feel like it needs to go. And that is a nice way to customize the user experience and let people theme your components. This is a really easy pattern to follow and gives your components a lot of ways to be expanded upon. So next, I want to look at, we have our alert box. And a common scenario for components in any application is we need to bind components to a list of values. So what I want to do next is I want to pull in a simple service that contains a state of objects. And then I want to bind a set of alert boxes to that data. And this is going to open up some opportunities for my component. So in my application, I have a services layer. This is very, very simple stuff. I have a logger service that generates random data. This code, really, you don't have to understand what the meaning of it is. Just need to know that at the end of the day, it generates some random data for us, and it creates a list of log items. So that's our basic service. And the way you handle state in Blazor is actually very easy. You can create any type of object and then register it with the dependency injection system, as I've done here. So we have our service container. We're going to add a transient object to it called logger service. And now I can use that state anywhere in our application. So I'll go back to my index page, and I'm going to add a directive here. So if I say inject, actually I have it here so you don't have to watch me type. I'm going to say inject, give the namespace and the name of the service, and I'm going to call this logs. So now I have those logs available to us. And just to show you that I have data there, I'll go ahead and render out a count. So I can say logs.count. Log items is the collection within the service. Log items count, and we'll render out a count of items in there. So I have 25 items, and I want to create a list-bound component that renders 25 alert boxes based on that list of items that we give it. A quick question here. How would we handle allowing a class on the outer and inner component? For something like that, we may want to use both approaches that I showed before, where you capture the class attribute, the normal HTML class attribute there. And then for the inner component, you may want to set up a special property that is targeting the inner value. So you may have a situation where, for example, I have my outer wrapper, and then I have something like a header inside, and I want to render a class here. I would then probably set a separate property for that. That is a named property. So I'd have something like parameter of string that is my header class, like that. So when you get into deep hierarchies like that, there has to be some way for you to target each individual one. You couldn't do that through a normal element attribute anyway, so you have to get a little more clever and do something like that. So we would then render that header class up here, like that. For the most part, if you're pretty handy with CSS, you don't really need to target things that directly. You can offer an API like that as a component developer. For the most part, if you have access to the class at the wrapper level, you can always define, and I'll type it up down here very quickly. You can always say div, and then you can either target the child element by its selector, or you can say if it has an inner header maybe, and then override the class that way. And then as long as the selector for this class is emitted in the wrapper, the child elements underneath will accept that class as well. So there's multiple ways to do that. It's always nice, though, if you offer an extra parameter for developers that may not be as fluent with CSS development. So it's always nice to give options to developers. So let's go back here. And thanks for the question, by the way. It was a good one. We're going to continue with binding a list of items to this collection. So we have our 25 items. What we want to do is create a brand new component, though, that is a list-bound alert box. So I'm going to go over to components again. And this time I'm going to add a new Razor component. And this component is going to be called, oops, I always do that bug, alert list.razor. There's a bug in Visual Studio that you can drag and drop items from your text box here into the view. It's kind of annoying. And now I have to go back and delete that accidental drag and drop, something I do quite frequently. So now I have my alert list, and I want to create a list-bound component. So let's go back again and look at how we can do that. So we're going to look at generic templating. So generic templates are a component that takes a generic item of T and applies that template to a render fragment of T. So this is similar to our child content, except this gives us a generic item that we can iterate through. So we're going to use something called a type parameter. This is going to make our component generic. It's going to be a component of T. When we use type param T item, this makes a component of T item. This component will be able to for each over a list of items and then render the values using a template, which gives us a usage kind of like this here. So we can have a list of some sort of item, and we don't really care what the type of that item is. And then we can define a template region that will iterate over all of the items in the collection and render that template out. So let's look at how we can do that. Inside of our alert list, we're going to go ahead and, oops, sorry, wrong one there. We're going to create a T item template. So I've got @type param of T item. So this is basically saying when we use this type, we have an alert list. Let me take the braces off there. The class type would be like this, T item. And IntelliSense keeps wanting to help me. I don't need its help right now. I'm kind of pseudo-coding here. This is the actual class type that we're trying to generate, is an alert list of T item. And that is what type param does for us. So type param gives us that T item. We don't need a UL here. I'll take this out of my templated code. Drop that off. The next thing we're going to do is for each over all of the items in the collection. And then we're going to use this type of syntax here. So let's explain what these two parameters do. We have a render fragment that is also of T item, and it's called item template. This name could be anything that we would like. I just chose item template to keep it generic. It could be alert template, it could be header template, footer template, you name it. We could have multiple of these per component as well. So it's very flexible. Unlike child content where it is implicit, this one we have to explicitly define where that template is by name. So I've got my item template, and we're actually going to pass it a value. And that's the value that is generic, and we're going to iterate over. So we've got our read-only list of T items here. And this is going to be our collection that we're binding to and iterating through and passing those one at a time to our template. So let's go back to our index page here, and let's try to make use of this. So now I have an alert list, and I need to give it some items. I have a parameter of items here. So I will give it logs.log items, and we will render out our alert list. And I have an error because I haven't specified that template region. And again, unlike the child content, I have to say item template here. And then I would render out my log items within this template. Now, if I run this again, I won't get an error, but I only have the count here. I don't have anything rendering out because I haven't specified a template yet. So inside of the template, for now, I'll just say at context dot, and you can see the IntelliSense automatically pick up when I start typing here. So I'm going to put message. This is a collection of log items, and they have an ID, a level, and a message. We'll go ahead and render that message out, and I'll run it one more time. And you can see I've just kind of spat out all of the values for that collection. There's no actual HTML wrapped around this yet, so it's just generating one big long string as it iterates through everything. So let's go back and set up a little bit of a wrapper around this. I want this to be an alert list. I'm going to render that same alert box control. So I'm going to kind of piggyback off of something I already have, and we'll go ahead and predefine an alert box there. So I have an alert box now wrapped around that template, and now you can see that I've rendered 25 alert boxes. Now what's nice is I'll go back to my index page where I'm using this component, and since it is an item template, I can actually specify what I'd like to render inside of that alert list. So in my item template now, instead of using just that message field and rendering inside the alert box, I'll go ahead and render a div with a heading tag and a paragraph tag. And notice I'm using log.id and log.message here. And before I was using context. Since this is generic, we don't really know what the compiler really doesn't know what to call that item, and it defaults to context just so we have something to target whatever it's iterating over, whatever is in context of that current iteration. If I want to name this, I can actually come up here and there's a new property that's automatically generated for us called context. And whatever string I type here, it will then call the context. So we can put a little bit of naming convention around what's getting rendered in that template. And now I can say, I want an item template, give me a div with log.id and log.message, and I can do away with that context keyword. So I have my h1 and the message, and you can see they iterate through all of the IDs in that template for all 25 items. So the next thing that I might want to do with a list-bound component like this is I might want to add some functionality to where I can modify my list by deleting an item. So this is something that developers new to Blazor usually stumble upon and get a little confused as to how they should handle maintaining that list and that state of the items inside of that container. The way I like to develop my components like this is I like to put the responsibility of maintaining state outside of the component so that the developer can decide how they want to maintain the items within that component's list. So for example, I have outside of my component a count. I don't need to ask my component how many items are being rendered inside of it because the state that I'm maintaining outside of the component already knows I have 25 items in that list. Same goes for deleting an item. If I want to delete an item, I want to offload the responsibility for doing the delete outside of my component so the developer can take that item out of the list, and then we will just bind the remaining 24 items to the list, removing the one that was deleted. I don't want to put those behaviors within the list itself and try to maintain the state within the list. It gets very confusing very quickly when you try to do that. So let's look at how we can do this the best way. So I have my alert list, and I'm going to go back to my slides really quick. I want to use something called an event callback. So event callback is a special event delegate for Blazor that triggers a component to re-render. So this is much like action is in just generic C#, but in the context of Blazor, event callback is an action that also triggers the component to re-render itself because something has taken place in the system that has changed the state of our UI, and we need to update the UI. I will put a little note here that this is a semi-expensive operation, and you really want to have these event callbacks at the top of the component, top layer of the component, the most outer component. If these are internal APIs, internal actions, or delegates that the user will not be writing custom delegates against, you want to handle those with an action and control the re-rendering on your own logic. If they're at the very top level and these are public API calls that you want to give to your developers, that's where that callback should be used. There is an expense at re-rendering the component, and it can happen unnecessarily if it's deeply nested within that component hierarchy somewhere, and it's not even being used at the top level by the developer experiencing the usage of the component itself. So we're gonna build a public level API here. We're gonna go ahead and expose an event callback. So when somebody clicks on a delete button, an event is triggered to delete an item, and we'll see how to structure that here. So the next thing I want to do is in my alert list, we'll go ahead and add another parameter. And this time the parameter is going to be an event callback of object. And this is going to be called onDelete. So that will actually be our physical property name that we bind our event delegate to as a user. Internally, I'm going to handle that delete by taking the current item and passing it to that event delegate and invoking that delegate and giving it the item that we're currently raised the event. So I need to trigger this somehow. So I need to add a delete button to my alert box. So inside of my alert box, I'm going to go ahead and add that delete button. And this is going to check and say, does this onDelete delegate have a delegate available? If it does, we'll go ahead and render the delete button. If it doesn't, then why show a UI component that we can't use? We'll go ahead and just eliminate the button altogether. So we can actually check here and see if there is a delegate available and then render the button. This is going to be a standard HTML button with a special class on it. So it looks like an X, so we can close it out. And then we're going to bind to the onClick event of the button. And we're going to pass that onClick event off to our handleDelete method in our component and give it the item that is bound to this the item in the for each loop. So now handleDelete, here we'll do a little whiteboarding here. HandleDelete, when somebody clicks on it, takes the item that's currently bound there and passes it off to the handleDelete delegate, which then passes it off to the user-defined method that comes from this onDelete event callback. So if we put those things together, we come back to our index page here, where we're using the alert list. Now we have to make use of this delete button. So I'm going to drag the code in here. I need a code block to wrap around this. So we'll say @code. And I'm setting up a method here called delete item. And this is where I can do my custom method calls here. This is what I was talking about, deferring the delete mechanics off to the developer to decide how to control the state that's bound to this alert list. So for me, this could be, the state for this could be held in a DB context. It could be an HTTP call that has to happen. It could be an in-memory list of items like we have here. Things may have to happen in order to delete an item successfully. So we don't want to remove that item from our alert list until the developer has told us that it's okay to do so. So what we'll do is, instead of trying to handle all that logic, we'll just pass them the item, and the developer can do what they'd like with it, and then they can modify that collection, which will in turn re-render the component. So in here I have delete item. I'm going to go into my logs. I'm going to say log items.remove. We'll go ahead and cast that off to a log item. And then up in my alert list, since I have that new property available, I can say on delete the item. And that will bind my alert list to my new method. And now I can re-render that component. And you'll see that I have 25 of them. And they are all iterating over this list and showing an alert or a delete button right here in the corner. If I click that button, my list counts down. So now I have 20 items left. I've deleted 5 of them. I can also do things like put confirmations in here. You name it, it's all customizable, because all of the functionality here has been delegated off to the developer to decide how I want to handle that delete functionality. Okay. You'll notice there's some casting going on. So I have object. I'm casting it to a log item. And in this alert list, you'll see I have a fragment of T item, a read-only of T item, and then event callback is of an object. And then my handle delete is T item. Why didn't I just make this T item? So we'll go ahead and make that T item as well. And you'll notice this is a common error that you run into. When I make event callback of T, and I look back at my index page, you'll notice that I'm going to receive an error. And the error message is that it cannot convert from Microsoft ASP.NET Core Components event callback to an event callback of Blazor, which Blazor Day is the assembly name. Log item is the class name that it's trying to convert to. So it's an event callback that can't convert to an event callback of T. So what's actually going on here? Well, inside of my alert list, if I look at my alert list here, I have complete scope of T item. My alert list knows what a T item is. It can infer that T item from the items that are bound to that list. This delete method, however, is unaware what t-item is. So if I try to go to delete item and make this a t-item, I don't know what t-item is in that context. That context only exists within the alert list. So you're going to see that doesn't work. If I say log item here, and I try to compile that, you'll notice I get cannot convert method group to event callback. So I still run into an error that I can't quite pinpoint. So what we actually need to do here is we can use t-item, but when we use t-item, what we need to do is specify a delegate that will imply the type for the compiler so it understands what t-item is. So you end up with a little bit longer syntax than you do by giving it just a standard object. So if we don't use object here and we use t-item, what we end up with is a method signature that looks like this. And I'll go ahead and paste it in there. Whoops. A second, pasted a little too much. Now I have on delete. We're going to take and let the compiler know we're using a log item in this event delegate. Not sure why I'm getting an underscore there. That should go away. It may just be a false positive. Looks like it is. You can ignore that little chunk of red underscore there. It's false positive. So this actually makes the compiler happy more than anything. So it's telling the system that I have an on delete of log item, and I want to go ahead and invoke the delete item with that argument of log item as the parameter. And then this will successfully run and do the same thing that we did before. Now, both of those methods work. We can pass back an object. We can pass back t-item. Just the one caveat to know about there is it will change that method signature. So it's up to you on how you want to develop your APIs for your consumer. For us at TaleLearn, we chose to continue with the t-item, hoping that Microsoft will add some more compiler functionality to be able to understand what the developer is trying to do and imply that. And we've continued on with that and just documented heavily that this is how you write your method signature. So that's a choice that we've made thus far. I've got just a few minutes left. It looks like about 13 minutes left. I have some other examples I can show you. And if you have any questions, feel free to start hitting me up with any questions that you have as I finish this out. And I'll make sure I leave a little bit of time for anything else too. So one thing you might have noticed so far is I've kind of lost the ability to write the CSS value for the alert list. Everything in the alert list is red, and it's an alert of danger. And I don't really have a way, since that alert box is encapsulated within the list, I don't have a way to specify that CSS class. So let's change that. Let's go back to our alert list, and let's add something that lets us specify how each individual template item renders this outer alert box element. So I have a little parameter here I like to call CSS Map. Now, if you're familiar with any functional programming, this should make quite a bit of sense. I'm giving the consumer the option to have a delegate that maps any value they give it to a CSS class. So I have a function of t-item. So I'm going to take in your templated item, and you're going to return a string based on whatever logic you provide. This is called CSS Map, and by default, that gives me an alert danger. So up in my code here, in alert box, I'm going to say class equals at CSS Map, and I need to pass it the item. It takes that full t-item. So we're invoking your custom function that takes an item and returns a string. And again, if you leave that to the default, the item gets taken in and thrown away, and returned the alert danger string by default. So there's no harm, no foul if you don't specify an alert map. Now, spelling matters here. Make sure I put 2 S's on class. So finally, we'll go back to our index. And now we can have some fun with our alert map, or my CSS map. And I'll set up a little pattern matching here. I'm going to use a new switch statement. And the new switch statement is pretty straightforward. Whenever my log level is warning, I'm going to go ahead and emit the string warning. When the log level is critical, I'm going to emit alert danger. And whenever the log level is error, I'm going to emit alert danger. And when the alert level is anything else, it will be of alert info. This is my CSS map. Again, it takes a T item, which is log item in this context. It iterates over, or it passes that through this the switch and returns a string. So it is a func of log item of string. Now, inside of my alert list, I can specify this CSS map, and I also call the function CSS map as well. So that parameter is CSS map with a value of this function CSS map. And it should automatically go ahead and iterate through those, and you'll notice it's mapping their log level to the style that I would like to give it. So that's the way you can add a little bit of functional flair to your components and work with mapping values across those lists. Now, there's other ways we can do this too. One of the methods that we chose, I like functional programming myself, but the CSS or the C# development community as a whole may not be on board with functional programming. So the approach that we've taken at TaleLearn for TaleLearn UI components is we use a little bit of internal reflection, and we have value properties that you can set by the field that you would like to bind to. So if you go to demos.taleLearn.com, I'll give you a little example of what that looks like. These are some of the components that we have for Blazor now. Drop-down list is an excellent example of how to do this. If we look at the source here in a drop-down list, let's see, we actually don't have it in this one. My mistake for not knowing it was not there. We'll go ahead and look at the actual documentation here. There is actually a text, here it is. There is a text field for a dropdown. So we can specify text field as the property on that object and the value field as the property on the same object. And then we use reflection internally to look for those fields on that collection and take the text and value and apply it to the markup where it belongs. So there's more than one way to get that process done. Reflection is one, and offering some functions that the developer can utilize is another. So that is about all I've got time for. Hopefully you learned a little bit about creating list-bound components with Blazor. You learned how to delete items out of a list of components and reflect that back in the state of the application, manage some CSS values and properties, learned about some of the major parameter types that are out there in the framework. Once you know they're there, I think you've got a lot of power at your fingertips. So we've got about 5 minutes for questions. Feel free to shoot me anything. Don't be shy. It's okay. Type in chat if you got something you want to know. You can find the resources for some of these examples are in not exactly in the same format, but in a very similar fashion in my free ebook. You can find a link for that at charbeneau.com, or you can also go to blogs.taleLearn.com, find all sorts of Blazor blogs up there. We recently ran a series on comparing Blazor to other frameworks to kind of give you an idea of how it stacks up versus React and Angular and Vue. So there's some good reads there. And there's plenty of examples on my GitHub page. And of course, I do a Twitch stream every Friday. If I'm not presenting at a conference like today, I would be streaming and doing Blazor demos there as well. So I don't see any questions coming in chat. Hopefully that's a good sign. And I taught you everything you wanted to know today. If you think of something later, feel free to hit me up on any of the channels here, on Twitter or Twitch, or my GitHub, you name it. Feel free to reach out. Seeing some good feedback here in chat, so thank you all very much for coming to my talk. And I hope you enjoy the rest of Code PaLOusa. Thank you all again, and you have a good weekend. Awesome. Glad you guys are learning something. That's great to hear. Thanks for the positive feedback. Appreciate it, Stephen.